Hello friends, welcome to this lecture. Today we are going to discuss the Newton's laws of motion. So here is Newton's first law of motion, and its statements is the Newton's first law is that an object continues to move at constant velocity unless acted on by external force, or we can say that without acting any external force body does not move from state of rest or continuous state of motion. Okay, so here some comparison is discussed, that is, unlike Galileo's horizontal motion law, this law applies for motion in any direction. Okay, so relating change in velocity to force, this can be explained in this way. That means this can only be done experimentally, and Newton did so many experiments. Care must be taken to make sure forces like friction etc. are negligible, small. So we have to ignore them. Okay. So take two objects made of the same materials, iron, one twice the volume of the other, and apply the same force. The one of with twice the stuff accelerates at half the rate. That's mean here some friction forces if we are ignoring, then it requires some much more force, and it is nothing but the change in velocity to force and acceleration. Many experiments lead to the conclusion that a given force, such as a spring extended by a measured amount, accelerates an object in the direction of the force at the rate inversely proportional to the amount of stuff in the object. The amount of stuff is called the mass or inertial mass of the object. It measures the object resistance to being accelerated. The object's inertia, it is denoted by m. Another part is force and acceleration too. It is also found that doubling the force pulling with two identical springs uh, doubles the acceleration. The bottom line is acceleration is proportional to the applied force, and of course in the same direction. Acceleration is inversely proportional to the mass. Unit for force, we already have a unit for mass is kg and acceleration meter per second square. So we define the magnitude of the unit force as that force which accelerate 1 kilogram at 1 meter per second. This unit force is 1 newton. Newton's second law, the relation between force, mass and acceleration can be written as F is equal to mass into acceleration bar, where the magnitude of the force F is measured in newtons, the mass is in kilograms, and acceleration is in meter per second square. This is the Newton's second law. F means total force. Newton's second law is F equals to ma, gives the acceleration of a body of mass m acted on by a total force F. Air resistance and friction contribute non-zero forces, which might or might not be small, so it can be ignored. A car accelerating along a road is also being acted on by gravity, but that is usually cancelled out by the upward force of support from the road called the normal force. Inertial frame of reference. Recall, a frame of reference is a set of axes like three perpendicular rulers to measure position plus a clock to track time, so motion can be precisely described. An inertial frame is one in which Newton's first law is obeyed. That means Newton's first law is valid for this frame. If frame A is inertial and frame B is moving at constant velocity relative to frame A, then frame B is also inertial. Keep remember that the moving frame B move with a constant velocity. Okay, then both are in inertial frame. Relative velocity and inertial frames. If a body is moving at constant velocity Vb in frame B and frame B is moving at constant velocity V relative to frame A, then the body is moving at constant velocity Va, Vb, Vv relative to frame A. For constant velocity V of frame B relative to frame A, the acceleration of a body measured in a frame A equals its acceleration in frame B, that is dVA upon dt is equal to dV by dt plus dVB by dt is equal to dVB by dt. Relative acceleration and non-inertial frames. If a frame A is inertial and frame B is accelerating with respect to frame A, then frame B is non-inertial if and only if frame B is accelerating with non-constant acceleration, that is variable acceleration. Examples: inside an accelerating car on a rotating carousel. A body is an accelerating car will only stay at rest relative to the car if acted on by some force. So now we have to start with the Newton's third law. If two bodies interact, the force on B from A is equal in magnitude to the force on A from B and opposite in direction. So force of A acted upon B is equal to negative sine F, that is force acted upon by B on A. In the example shown here, the globe suffers a force exactly equal in magnitude that felt by the face. Action and reaction. Newton's third law is often stated as action equals reaction. The action is body A pushing on body B. The reaction is inevitable opposite force B pushing back on A. Very important that the action and the reaction always act on different bodies. More action and reaction. If a car and truck collide, the force of the truck on the car equals the force of the car on truck, but an equal force on a smaller object will have different result. These are the references used to create this video. Thank you, friends.